welcome back. So now we're going to learn about a little bit more about midsegments. This is in your notes, right? So let's add a little bit to that. A midsegment of a triangle is a segment that joins the midpoints of two sides of the triangle. Every triangle has three midsegments which form the midsegment triangle. So let's talk a little bit about the midsegment triangle there. All right, so our midsegments are XY. And that is parallel to PR. So let's just kind of mark that on our diagram there. Right? And we have YZ, and that midsegment is parallel to QP. It's also, by the way, parallel to QX and XP, that whole segment, or any part thereof. Oops. And now I should put 2, right, because I don't want you to think they're parallel to the blue ones. And then our last midsegment here is QZ, right, and that one is parallel to QR. Right? And so we know also that when we have parallel lines, we have certain angles that are formed, and certain angles that are formed by parallel lines are congruent. Right? So let's go through all of our parallel lines. Right? And I may outline in another color just so that we can see the transversal. Right? So let's start with the blue ones. They're kind of easier because they're horizontal. Right? XY and PR. Right? So for instance, that line right there, that segment QP, that would be a transversal. You don't have to write this part. You can just write the words I write down because I'm going to keep moving that line around. All right, that would be a transversal for segments XY and PR, right? Because that line intersects those two segments. And so we have an angle here created by that transversal and each of those parallel lines. Notice that that angle there is in the same position on the two lines, right? It's to the right of the transversal and it's above one of the parallel lines. And we know that if you're in the same relative position, you're called corresponding angles. So angle, you can add this to your notes, angle QXY is congruent to angle QPR. And that's because those are corresponding angles. Now I left a little bit of space because maybe there's more of these corresponding angles, so we don't have to keep writing it. Corresponding angles formed by parallel lines. And we'll abbreviate parallel with the symbol. And so now I'm going to move this out of the way. Now let's talk about another set of lines. So we'll have a different transversal. Let's talk about we could talk about the red lines. Yeah, let's talk about the red lines there. All right, so we have two different lines that intersect them. Actually, I shouldn't have erased it. Let's keep the same transversal. All right, they intersect, that line there, QP intersects QR and XR. And again, right, we have an angle here and here, okay, that's formed by the two parallel lines and that transversal. This time, it's to the right of the transversal, and I guess I would call that below the parallel line, right? And that's angle PXR. And that angle is congruent to angle PQR for the exact same reason. Again, corresponding angle, same relative position, same side of the transversal, same position on the line. Now I think we're done, but maybe I better leave that there just in case. All right, so now let's talk about so we talked about the red lines, we talked about the blue lines, we haven't talked about the green lines. let's talk about the green lines. All right, so this line right here, that one intersects both of the green lines, PQ and YZ, right? And again, we're going to have angles formed off those. I don't think I chose the best line, actually, for the ones. Yeah, let's use either a different pair of lines, because I already have those. No, actually I don't. I didn't do that angle yet. Let's see. Do I want to use that for the... Well, we could. One of the angles is already marked. That's why I was thinking that. All right, we'll use it anyway. All right, so I already have one of them marked. Right? So the angle, and that's angle PQR. Right, so angle PQR, the corresponding angle is already marked. Right, so it's formed by, this time, the green lines and that transversal QR. Right, so we got the same angle being formed by two different sets of parallel lines and transversal, but that's okay because we have another angle that's corresponding along the green lines there. The green lines intersected by segment QR. And so those are also congruent. So I put 2 marks again because it's the exact same measurement. So that's angle ZYR. Let's see, do we have any more? Let's move that out of the way. Actually, do we want to use this for anybody else? Yeah, you know what? Let's use it for the blue lines. All right, so formed by the 2 blue lines there, and intersected by the transversal, we have this angle here. Again, this angle corresponds to this angle. Right? Same position on our blue lines, same side of QR. And so that is angle QYX, and that's congruent to angle QRP. And I think you're starting to see something here. You're starting to see, hopefully, let's move this that way now. Oops, not you. That, oh, I'm trying to move the transversal out of the way. There we go. That we have a lot of angles that are congruent to other angles. We have a lot of pairs of corresponding angles. Do we have any others? Well, what if this is the transversal instead? Right there for the red lines. No, actually one of them is going to go outside the triangle. That one's not a good one to use. Who's left? Well, anyway, so your eyes don't get all buggy. Keep looking at this. Let me just tell you where I'm going without necessarily finding every pair of parallel lines there. All right, so we have some other angles that are congruent. I will tell you that, and we could, oh, here, if we use the red lines and the green line, but different angle than I was looking at. Right there, we have this angle, right, formed along, oh, sorry, wrong transversal, this one here. That angle there formed along that transversal, and the 2 red lines there. And that one's already been marked before, right? So that was angle QRP. Right? And so that was angle, who did we just mark? XZP. And you might wonder how many of these angles are congruent to one another. Not only do we have corresponding angles, by the way, we also have alternate interior angles if we wanted to go looking for those. Right? And actually, we could mark more of the angles congruent. You can already see that angle, or triangle QXY. Notice all the angles in QXY are marked congruent to the angles in XZP. Now Now I only put the similar mark there. This means similar because all I've marked is angles, right? But actually, we're going to learn some more things about these the triangles and about these measurements. Right? So, for instance, we know that blue line there is half. XY is half of is 1/2 of PR. So that would mean if each of these are if PR is twice as big as XY. And Z there is the midpoint, it's going to divides this into two congruent segments. If XY is half, it's going to be the exact same, right? If I had two XYs, I don't know why I put ZX. If I had I was writing two, that's right. Two XYs, that would be equal to 1 PR. Well, I have no idea why that comes up once in a while. Well, PR is the same as PZ plus ZR. So if I was just looking, for instance, at PZ, XY is the exact same length as PZ, which means now we have a corresponding side as well. So not only are these similar, they're actually congruent. As a matter of fact, all of those mid-segment triangles are congruent. And we could sit here and prove it. However, I think we've proved enough to know that well, at least we got one set, and if we kept on going, we'd have all of those. So all of the, so I shouldn't say all mid-segment triangles. The mid-segment triangle is congruent, a better way to put this, the mid-segment triangle, because the only one of them is a mid-segment triangle. The mid-segment triangle is congruent to the other three triangles that you see that are created by the mid-segments. Theirs aren't mid-segment triangles. The only one that's a mid-segment triangle is, let's write in a different color here. Actually, let's write in yellow. The only one that's a mid-segment triangle is this one right here. That's the mid-segment triangle. The other ones are just kind of created by all those mid-segments. Oops, can't write in yellow. That might come in handy later on. Right, so there's actually a lot of space you could write on the sides there. I don't have too much more to write on the next slide. All right, so just a little information about our mid-segment triangle and all those other triangles. So, but not only are all the mid-segment triangles are congruent, one other thing. Our mid-segment triangle, matter of fact, any one of these triangles is similar. We'll add that in here. And similar to the original triangle, PQR. We might prove that in one of the other slides, or we'll save that for another time. However, I will give you that little bit of information. Right? And we could see that would have to be true because similar triangles have all the same angle measures, and we can see a lot of triangles there with the exact same angle measures, including triangle PQR. All right, let's do a little bit more with mid-segments. Now let's do some solving. That we've talked about them so much. So a segment connecting the midpoints of two sides of a triangle is parallel to the third side and half as long. So here we just have one mid-segment. DE here is going to be parallel to the opposite side there, AC, and it's going to be half as long. So it's actually pretty easy to solve with mid-segments because generally you're either doubling something or dividing it in two. You have this in your notes, and I want you to add that little piece of information there. So I added a point there, so we have a mid-segment triangle. All right, so a mid-segment of a triangle is parallel to a side of the triangle and its length is half the length of that side. Already in your notes is written that DE is parallel to AC, and DE is half of AC, but I also want you to write this because sometimes it'll be easier to solve this way. So if DE is half as long as AC, it must take 2 DEs to equal 1 AC. I also added point R there so that we would have a mid-segment triangle. So DR is parallel to BC, and it's also half the length of BC, and ER is parallel to AB, and also half the length of AB. All right, so just a little bit to add to your notes. I'm going to go on, but if you need a little time, go ahead and write that down. Let's do a little bit more solving. All right, so we want to identify 3 pairs of parallel segments in the diagram. Super easy. All right, so AB is going to be parallel to the mid-segment that does not intersect it, XZ. And BC, parallel to the mid-segment that doesn't intersect that one, and that is XY or YX, whatever you prefer. And then finally, AC is parallel to YZ. Really, you just got to look to see which one is going going the same direction. We know that the mid-segment and it has to be parallel to the opposite side. It's the only side it doesn't intersect, and it kind of looks like it's going the same direction. All right, so easy cheesy lemon squeezy. Figuring out which ones are parallel? I hope so. All right, so in the diagram, ST and TU are mid-segments. This one is not in your notes. ST and TU are mid-segments of triangle PQR. We want to find PR and TU. All right? So PR, where's PR located? It's right here. Always write the relationship. We're looking for PR. Remember that PR is going to be twice as long as ST because ST is the mid-segment. I always isolate the one I'm looking for. So PR is just going to be 2 times 8, or PR is 16. How about TU? Well, TU is half as long as PQ, right? The one that it's parallel to. Maybe I should color code them. So this one is half of this one, and PR was half of ST. All right, so that means that TU is 1/2 of 10, which is 5. So I do always want you to write the relationship. You're a lot less likely to make an error when you're thinking about how they're related. Let's do another problem. This one is in your notes. All right, so in the diagram, ED and DF are mid-segments of triangle ABC. Find DF and AB. All right, so let's find, we got to find DB and we got to find AB. And to do that, we got to find X. Right? So let's think about the relationship between AB and DF. You got 2 ways to solve it. I'm going to solve it both ways. When you're actually solving, just pick a way. But let's see which one was easier for this particular problem. Right? So I could solve it one of 2 ways. Either I could say DF is half of AB, right? Or I could say that DF. So if DF is half of AB, it's going to take 2 DFs to equal 1 AB. Be careful on that. Sometimes students reverse that because they think, oh, DF is half as long. I got to put the half with DF. No, you got to put a 2 with DF because it's half as long. It's going to take twice 2 of them, right, to equal that same length. Right, so DF is 3x minus 4, and that's going to be half of 5x plus 2. And actually, I think we're just going to write the equation and see which one looks easier. Right, so 2 times 3x minus 4 is equal to 5x plus 2. And maybe for just this one, just so that you see you get the same number, we'll do this one twice, but we won't do it again twice. I said, now which one looks easier to solve? Would you rather distribute the half or distribute the 2? I think I prefer distributing the 2. Okay? So sometimes it's a good idea to write them both ways and say, yeah, I like the second method. We'll solve it out the first. You know what? I'll teach you a quick way to solve it out the first one, so we will. This is what I would do rather than distributing the 1/2. If I did write it like this and I was going to go with this equation, I would just multiply both sides by 2, right? Because now you've got 2 times 3x minus 4. Half of 2 is 1, and that's just going to be 5x plus 2, which is what you have right here. A lot easier to solve, all right? So if you accidentally, if you don't want to cross it off, you could just multiply both sides by 2, and there you get to the equation that's a little simpler. Let's solve that little bit simpler equation, the one that doesn't have a half to distribute. I wouldn't mind, by the way, distributing a half if it wasn't a 5, and I wasn't going to end up with a fraction. So 2 times 3x is 6x minus 8. Got to distribute the 2. And then we have 5x plus 2. Now this is actually a pretty easy equation to solve. So we'll subtract 5x from both sides. So now we have x minus 8 equals 2. And we just add 8 to both sides. I'm just going to move everybody up just a little bit. And when we add 8 to both sides, we can see that x is 10. And there we go. Now that we know what x is, now it'll be easy to find the rest of them. All right, so df is just going to be 3 times 10 minus 4. So that's going to be 30 minus 4, and 30 minus 4 is 26. You have 2 ways to solve for AB. You could do 5 times 10 plus 2, or you could do 2 times 26 because it's twice as big. Either way, you're going to get 52. And there we go. Another one solved. I'm debating whether or not we got one, whether I want to end the pod. Oh, I only have one podcast, one more slide. I say, let's finish this slide. All right, so let's take care of these 2. And then the last slide there is going to be done at another time along with the review. So you'll be all done with these notes except for one. We want to find the angles and sides, the angles formed by sides and mid-segments of a triangle. Right? So now it's a good idea we went over all those congruent angles. We want angle CBD. Angle CBD is this angle right here. Right? We know this angle is, and it's hard to see, that angle right there is 26 degrees. We have parallel lines, and the ones I'd like to use are these ones. We have these parallel lines, and they are cut, one of the few relationships I didn't do, they are cut by that transversal. So BD here is a transversal. We'll write that down. That intersects AC and DF. And we know that AC is parallel to DF. All right? So what are those angles called? Angle CBD. Angle CBD is congruent here to angle FDB. Do you remember what kind there are? They are alternate interior angles formed by parallel lines. So they have to be congruent. So since they're the exact same measure, if FDB there is 26 degrees, then so is CBD. All right? So make sure you write that down so you can recognize you've got parallel lines here, so you're going to have some congruent angles. JF Everything else is in the other triangle. So we're done with that one, aren't we? Although we should have I guess it didn't, is it on yours? It's not on mine. Let's add this because there's all kinds of things we could solve here. On the other side of your notes, we've got, let's find the measurement of BD. I think this got left off. And AC. All right, so BD is the green line that we just put in there. And note that it's parallel to AE. And not only is it parallel, but BD is equal to 1/2 of AE. That means that BD is 1/2 of 17, which is 8.5. I'm going to move the AC down. So BD here equals 8.5. AC, write in a different color. AC is parallel to DF, and it's the side of a triangle, so AC is going to be 2 times the length of DF. That means AC is 2 times 6.2, or 12.4. Right, so it's really easy to work with mid-segments because you're usually dividing something in 2, or you're doubling it, or you're remembering which angles are congruent because they're formed by parallel lines. All right, so now let's find PM. PM is right here. And PM is half as long as the opposite side there, LK. So that means that PM is 1/2 97, which is 48.5. And then MLK. So angle MLK is this angle here. And where do you suppose that 36 goes with something else? Oh, so we're going to solve using the 36 too. We got one other thing that's not written here. Notice here we have an angle right here, and I think you can see that angle MLK is congruent to angle JMP because those are corresponding angles formed by parallel lines. Right, so if JMP is 102 degrees, so is MK. Last thing we're going to do is find the measure of JL. Right, so JL, we'll put it over here. Oops. Pen got stuck. JL is that green line right there, and it is twice as big as PN. It is twice the length of PN. Therefore, if PN is 36, JL is going to be 72. And there we go. We have solved all of the problems. So you should have everything done now except for there's one last thing in your notes, and I'm going to tack that on to a review later on. Make sure you found the segments and angles that for some reason were left off your notes, right? And I'll see you in the next podcast. Bye for now.